All right, we've covered some pretty big concepts already. Scatter plots, correlation. The next big concept in this week is regression. And the three main topics that we'll study here will be the line of best fit, making predictions, and then, of course, StatCrunch calculations. So let's unpack that first topic, the line of best fit. So if you've been astute, you might have noticed that on these examples we looked at in section 2.4, where we had scatter plots with blue dots, you might have noticed that we also had pink lines running through the middle of them. I didn't address those lines before, but we're going to talk about them now. So that each one of these lines is called the line of best fit. The line drawn through the middle of a scatter plot is also called its regression line, or line of best fit. Analogous to a point estimate, this line is a best guess or prediction for where the population will be centered. So one thing that we've done in this course is to construct confidence interval estimates for one variable. And so those were graphed on a one-dimensional number line. There was a point estimate in the middle, and then there was a plus or minus margin of error from there to the left or right on the number line. Now, since these problems are inherently two-dimensional, our point estimate is no longer a point, but it's this line. So you can see that basically our best guess is this line, and then these points are falling on a plus or minus margin of error above or below that line. Now, I know this takes us way back to 7th grade or so, but every line has an equation. The equation of a line has this, there are a few different forms for it, but one of the most common generic forms for the equation of a line is written in point-slope form. Y equals mx plus b. M stands for slope, and b stands for y-intercept. So those variables are pretty universal. We've basically seen them before in very generic contexts. The slope of a regression line is really a pretty interesting variable because it tells us that for every unit that variable x increases, variable y will increase by whatever that slope is. So it's a really nice quantitative comparison between the two variables. Now, you might notice that this y has a hat on top of it. So the hat is basically just a symbol for predicted, or the y value that you would see on this line, as opposed to the y value that you would see on one of these other points. So, for example, on this graph, if x is 3,500, then y hat is the height of that pink line right above that point. Whereas this blue dot here has an x value of 3,500, but its y value is a little bit below that. Right, so y is a variable. Each one of these different points has a y value. Some of them are above y hat, and some of them are below y hat. The line represents y hat in the middle. Predicted value. How do we get to see this line? Well, when we go to StatCrunch and graph the scatter plot, we're just going to select one more box here, the overlay polynomial. Let's go back to StatCrunch and do that again. So when we were in section 2.4, how did we graph a scatter plot? We went to graph, scatter plot. We selected the x variable and the y variable. Now before we jump to compute, we have to scroll way down. Here it is. I missed it the first time. Overlay polynomial order. It's easy to miss. I just missed it. And then we have to select polynomial order 1. What does that mean, by the way? Polynomials are graphs of curvy things on a plane. But if the polynomial order is only 1, then the curve actually becomes a straight line. Order 1 means x to the first power. So a straight line doesn't have any x squared or x cubed in it. It's just x to the 1. It's a first order polynomial. So yes, there are such things as parabolas of best fit or cubic curves of best fit. Don't worry, those are well beyond the scope of this course. We're going to keep it to linear correlation only. So anyway, once that is checked, and by the way, make sure that this radio dial is selected best fit. I think that's the default. And then when you click compute, you not only see the blue points, but you also see the pink line of best fit running through the middle. And look at that. When I hover on the line, it actually shows me the equation of that line. Next, our lecture notes discuss making predictions. I want to introduce some terminology here. So the variable x is generically referred to in this context as the predictor variable, because what we're going to do now is basically choose a value for x, and we are going to use that value to make our best prediction about y the whole time. So in this case, the number of representatives would be the predictor variable, and it would be used to predict the whole time y, which will now also be referred to as the response variable, because we're going to think about the whole time as being a response to or depending on the number of representatives. So for instance, we might say, I'd like to open up a new call center with 20 representatives in it. How long should I expect the hold times to be? Of course, the best answer is, well, let's go to x equals 20 and then just go straight up until we reach the height of this line. And whatever that height is, we can see that it's maybe about 14. That would be the predicted value. And StatCrunch will do this more precisely for us in a minute, but conceptually this is what we're doing. I also want to make one other caveat, that we only use this line if there does appear to be a correlation between x and y. So if you recall, there are some situations where x and y give you a scatter plot that looks like just a cloud. And in the extreme, the line of best fit here would be totally horizontal. If there's absolutely no correlation, then the line of best fit just becomes totally horizontal. It doesn't slope upward or downward when x changes, because x is just not affecting y at all. And in that case, the height of that line would just be the average value for y. So if we find out that there is in fact no correlation between x and y, then the best prediction for y is just the average value of y, and it doesn't even matter what x is. All right, so just in case you're tested on that issue this week, that's what it is. All right, now let's use StatCrunch and crunch some numbers here. So on StatCrunch, we're going to be using this regression menu now. We're going to click Stat, Regression, and then a simple linear regression. And I'm ready to illustrate this with the call center again, so let's close this. Stat, Regression, simple linear regression. Select your columns, representatives, hold time. And just for now, I'm going to leave it at that and then click Compute. We get a lot of information going on here. I think I can maximize that. Okay, so this summarizes that the dependent variable is hold time y. The independent variable is the number of representatives x. Remember that we've just learned new words for these in this context. The independent variable is also known as the predictor variable, and the dependent variable is also known as the response variable. Okay, this is the equation we're looking for. The hold time in minutes, y, equals 20.66 minus 0.31 times the number of reps, x. Okay, let's be careful about the order here, because when we write things on paper, we usually write y equals mx plus b. We usually write the x term first, But in regression, for some reason, the intercept is usually written first. So this is your B number, the one that's written first. 20.66 is B. And negative 0.314 is the M value, or the slope. It's reminding us that the sample size is 9. It gives us R. It gives us R squared, which we're going to use shortly. And these two key numbers up here, the 20.66 and the negative 0.314, are also reiterated here. So it reminds us that the 20.66 is the intercept and negative 0.314 is the slope. Don't worry about these other values here for now. I just wanted to show you how to get this regression equation. There's more? I didn't even know you could click. Oh, there's a graph, the scatter plot. Okay. There's the line of best fit. All right, let me close that. And let me run through this one more time, but I'm going to add something different now. I'm going to make a prediction. If we open up a new call center with 21 reps in it, we're going to predict the average hold time. I think I've gotten ahead of the lecture notes a little bit here, so let me, or the examples. Let me go back to the section 10.2 examples. Find the regression equation. Okay, so we just got that. I will remind you what it is here. So we've got the regression equation y equals 20.66 minus 0.31x. Let's complete the following table. We've talked through most of this already. So the predictor variable has the symbol of x, and the problem-specific term or value here is the number of representatives. The symbol y hat is used to symbolize the predicted value of y. In this case, the predicted hold time. That's a function of x. The slope of the regression equation, symbolized as m. In this case, what would that refer to? It always has units of y over x. So minutes per rep of decrease. And this one has a negative coefficient here, right? So basically, for every new representative we add, we would expect the average hold time to decrease by 0.31 minutes. And then the number 20.66, oh yeah, that number here was negative 0.31. The number 20.66 represents our symbol of, I guess we could call it B, which is the intercept or starting point. All right, question 3. Here's where we get into our prediction. Suppose that this company plans to staff 21 customer service reps at its Juneau location. A, would it be appropriate to use the regression equation to predict the average hold time at Juneau? Remember, this has to do with whether there is a significant correlation between X and Y. And we found in this example that they are significantly correlated. We did that in a different video clip. So the answer is yes, because these variables are correlated. Okay, so then what is the best predicted hold time in Juneau? If we plug 21 in for X, so we could do this the old-fashioned way and just replace this X with a 21 and put it in a calculator. That would work. But of course, as you might expect, StatCrunch does that too. And when we do that, we start the same way: stat, regression, simple linear, select your columns, and then, prediction. So if we want the X value to be 21, then we can compute. And in this bottom table here, it says predicted values. If X is 21, then the predicted value of Y is 14.06. So with 21 reps at this call center, you would expect the average hold time to be 14.06 minutes.